Alright, so in this video what we're going to talk about is going to be a motion output cam. Okay, so this is going to be actually an ability to do an MAOC command, right, with basically an instruction following a position of a servo to actually control the output commands of an actual output card. Now, I want you to note there's a couple things about this I want you to actually understand when it comes down to this. Now, when you're doing, and I don't actually have it set up this way right now, but if you're doing an output card, you need to make sure your output card is set to scheduled data. Okay, what scheduled data does is it allows you to actually go in and control that through a motion axis output cam. Okay, so this is what this is, the MAOC, and this is basically how it's going to function, right? So what I've done is I've actually already set up the, in this program, I've already set this up for the motion group. Basically, a single axis. It is a hard axis, a real position servo axis, right? Then I've actually set up the actual output cam. What we're doing is we're utilizing just a generic output cam, and we've made a UDT for this so that you can actually see the cams come on and the bits come on, so that you can actually see that live and you don't actually have to have everything accordingly, working with this actual output card. Now, what I want to also bring up too, a very important aspect is the drive revolutions we have set currently matches the conversions we have to actually roll over, so that it is 1 revolution per actual cycle. So with all that said, I want you to understand, so when you see this run, you're going to see these outputs come on and come off, and we're going to utilize this through this actual cams that we have, or the actual trends that we have built, right? So what I've done is I've actually came in here and singled these out and put these into an isolated graph instead of having them a single graph, so you can see them better, right? And we're going to actually run those and show you that. Now, I want you to understand a couple different things about this this cam profile. Okay, so first and foremost, then again, coming in here looking at this, the cam profile, you can basically zoom to fit this. You can see that the way the profile is going to be. Now, this is preset. Okay, so I have this actually preset. You can build this cam on the fly if you want to, but just so you know, you need to have certain things built when you build this cam, when you're doing the actual, like say for instance, if you were to utilize this tag, the actual motion control tag right here, you would basically want to utilize these features and stuff like that, right? So and what I mean by that is I'm saying, okay, so if you're doing that, you're coming in and saying, okay, the left position is here, the right position is here. Okay, so that means that's when the positions are going to, if this is a position-based system, and it depends on when you have your latch, right? What do you have your latch set at? Do you have your latch set at a position and your unlatch set at a position like we do on bit 0 here? And if you do, like bit 0 is a position on our latch, if you would, and then the position off as an unlatch, right? So again, so think about that, right? So now if I have the latch as a position and enable, then I have a position and enable. It works a little bit different. Now if I have it in enable, it works a little bit different, and then position and duration. Now duration, and that's where this gets a little bit more, I guess, depends on your control atmosphere. Now I'm showing different examples here because again, this depends on your control atmosphere, right? So you could be doing blow-offs, you could be doing a cut machine. Let's just say, for instance, you had a like a food processing thing, like say for instance like a cookie cutter, or and it was like a long wafer bar or something like that, when you wanted to measure a certain distance, and you said, oh well, every, when the position of the servo is here, when the conveyor position is here, we want to actually cut that, right? We want to cut it in a certain position. Now that would be position and position, right? Now you could do position and duration for like a blow off, like an air blow off or something like that, and that's where this duration would play, right? So that's where the duration right here would play, and then you can have enable and duration. So there's many different setups that you could actually do, and there's you know, if you needed to look up exactly what these did, you know, again, this all depends on what you're doing. This all really depends on the atmosphere that you're controlling this in. So understand that. So again, the best atmosphere for duration is something you want to really control for a set period of time. You know the time you want to set it, but you know the position you want to trigger it, right? So this is a position. I want to trigger it on a position, but I don't want it to actually, I want it to actually go for a duration, right? Now, and that's understandable, right? That could be an air blast or something like that, or that could be something of that nature. Generally, that's a good setup for an air blast, right? Like if you wanted to blow something off of a conveyor, or you wanted to maybe shoot air into a bag to open it up for the next station that would be loading the product inside of the bag. Again, a very good atmosphere, because again, you can control an output based upon a servo's position, right? So say you're moving a bag down, right? Say you're moving a bag down an assembly line, and you have jaws that open it up. What you could do, oftentimes what we've seen in the past, what we've done in food industry, is we've actually opened it up slightly and then blew a burst of air in there. Now, how would we know we were in that position? Is we could reference these servo axes, right? The axis right here, and again, that when it comes, the reason they call it an axis really is based upon a mathematical equation that goes back to math altogether. So, but if everybody wants to know where the servo acts, the reason servos are called axes and stuff like that, that it's just a little tidbit there. So you get a little bit of that when you come in and watch some of these videos. I'm trying to make these videos more educational and better as we go, because again, like the more we know, the more we grow, and that's the better atmosphere. All right, so I want you to, now that you see the way this is done, and I want you to note too, you can come in here and copy these and come in here and insert these and paste them and do different things, but you have to be offline when you do that. Now, that's not saying you can't edit. I can edit this right now. If I want to change this from, like right now, from duration to position, then I can just click right there, click apply, and it will take. Now you cannot do that while that is running though, right? But I can actually do that while I'm sitting still and it's not active, right? Okay, so it is in run mode, and this is a good way to go to your fit. If you make a change in here, you can come in here and change that and zoom to fit, or zoom like that, right? You can zoom in, zoom out, you can see how everything is. I like to zoom to fit. You can kind of see it a little bit better, and you easily do that. Or you can come in here and zoom out how you want it, right? And we're going to see that in the trends. So with that said, let's go ahead and do this. We've got some simple logic for this control. And again, we have the rollover set to 1 revolution per minute, or not 1 revolution per minute, but 1 revolution of the actual servo. So what I want to do is actually cut the servo on, which it is. Actually, let's cut it off. I like to cut it off, and then let's cut it on. Okay, let's home it just to get a good start. Okay, so now we've homed our servo. We have this home set to a certain thing, so just note that home is going to be, the homing is to a certain point, right? So we're going to actually index it to a certain speed. This is indicated to a feed forward, and we're going to run, and then we're going to run to a certain speed, right? But again, we're going to run to a certain position from that speed. Okay, so just note that if I moved it out of position, if I were to cut this off, let's cut this off, cut it off, and I moved it. I want to show you that, and I moved it, right? And then I come over here and cut it on. Well, actually, I don't even have to cut it on. I can just home it. It's going to move to that position. Now that will cut the servo on as well, so I don't necessarily need to come over here and toggle that. But with all that said, let's actually go and toggle the jog. Okay, so now we're jogging. All right, so everything is running. When I open up this first one, I want you to see this rollover here, right? The rollover is actually working in conjunction with everything. See that rollover? That's the actual master position, okay? And you can actually see that the servo is, you know, turning on different bits. But let's come in here and see why. Oh, we actually errored out here, so that's a good indicator. So let's actually come in here and figure out and stop this. So what we can do is we can stop the servo. And I believe, I'm not sure why we errored out. Let's see the cam. Oh, the mission action status is on. Okay, so let's cut that servo off. Cut the servo off. Let's cut it back on. Cut it back on. And I believe we cut it back on. The reason why it errored is because we cut it back on and then we homed it, right? So sometimes, in the way we have this specific setup, is we need to be in a set position when we're running, or we need to be in a set position when we're actually using the system. So now our cam is actually, our output cam is actually on. It's functioning. You can see it's turning on different bits. I can show you that coming in here. If you look, and now it says the 13, 14, 13, 14. That's just cutting on different bits here. This is like, say for instance you were looking at your output card, you would be cutting on these actual outputs. So let's come in here, see that, and let's see the outputs coming on and off. So this is why I do a different style trend, because if you look, if I do the other style trend, if I don't do an isolated graph, then it looks like this. Kind of hard to read, right? But if I do an output, trend, and I want you to note too, if you do have trouble with video quality, just make sure you click the gear icon on the video below, and you can adjust the video quality to the best video quality you get from this. Because again, I do record in 1080p and I record in 4K, so you should be crystal clear in the video. And if you do have a video quality issue, generally you're going to get the best from that gear icon, and that's depending upon your internet connection. So back to this though, on the isolated graph. So when we're coming in doing the isolated graph, and we can show that, right? We show that actually running, and we show the actual system working. So in the second one, and again coming in here, we're actually controlling these bits a little bit different. Let's speed that up a little bit. Let's come in here and let's speed this up to like a 2.0. Okay, so now we're running a lot faster. And let's come in here, and you can see that the output cam is running faster. Now that's based upon, again, the positions that we have it. Oh, and I'm pulling up the servo again. Sorry about that. I wanted to explain the servo, the way the servo was set up, so you understand the way we're getting by with some of the attributes we have here. So our starting cam is at 0, and our ending cam is at 1. So we're going from 1 to 0. So the cam that we're monitoring in this MAOC is only from 0 to 1. Again, that's why I explained my servo. The way the servo was set up, it's set up between 0 and 1, right? So the rollover is only 1. It's going to happen at 1. So if you understand the way the servo servo is set up, and the way the conversion status and stuff like that is. Now we can do absolute position as well. You know, you can come in here and do absolute position. You can do compensation. If you wanted to compensate for different things, you can compensate, throw compensation in there, and then come in here. Of course, you have to re-index, so I'm not sure if we re-indexed to do the compensation. So if we came in here and we were to cut this off and on, stop and start. So stop and start. Actually, the thing that cuts it off and on is the off. So we're stopped right now. We're off. Okay, so we're back on. Coming down here, we're in IP. Good. We jog again. Coming in here, and now we're back on. And we can see this right here. Now, if we look at our compensation is starting to look a little bit different. Now again, that goes back into adjusting the compensation down here. Like we have these set. You know, if you wanted to add and adjust compensation on the fly, you could do that, right? Easily see. But again, that's adjustable, being the fact of you have to re-index that cam. Now, when it comes down to it, there's just all this is one's looking at the commanded reference and one's looking at the actual. So that's why this little bit right here is called reference absolute, because these are set up identically. They're both identical, right? They're feed forward, they're forward. The output cams and everything we're using are there. The only thing different is one's looking at the servo's actual position and the other's looking at the servo's commanded position. Oftentimes servos are more of an assumption to get them faster, to make sure the reaction of the logic of the actual PLC controller is understanding what's going on. So because the course rate update of the actual servo is what keeps us in line and keeps us happy. Now granted, this is cycling the max time of an actual less than 1 millisecond. So the base course rate update is 6 seconds or 6 milliseconds. I'm sorry. So just come in and understand that that's where you're at, right? So this is kind of the drawing factor, and we are using. So if you notice, we are using a UDT in here. This UDT is specially made. This UDT come in here. This UDT is specially made for motion enable. It has everything you need for that. It has a couple different things for this. You know, the disable controls, and again, this is something that is more custom made. But again, I wanted to give a good example of using an MAOC and kind of understand the way that things are working, the way you understand the way I guess the best way to understand how the actual, and let's put that back to fit right here, zoom to fit. So the best way to actually understand the way this output cam is going to fire is to understand the way your servo is set up. Okay, if you understand the conversion rate of your servo, you're going to better understand what's happening in this, right? So you cannot set any of this if you don't understand the servo, the way the servo is actually set up. So that's again why we talked about the conversion constants, and we talked about the revolutions, and we talked about we're rolling over and resetting every revolution. This is why I would like to come in and show that real quick. So if you looked at, and you actually seen that if we monitor tag status, we can actually see that the rollover, if we go right here, the actual position, this actual position is going to again roll over at a certain thing. So you see it's actually running up pretty slow, but you see actually it's the rollover is probably you can't see it's actually faster than what we can see right here. So that's actually and if we slowed it down, which we can right here, so if we go 0.5, slow it down to 0.5, and then we go back to monitor, you probably see it a lot better. Actually, let's go back to monitor tag right here. It's easier to find, and you can see it actually a lot better now. So you see the rollover is every one instead of just constantly letting it run. So that's where we're getting by. Okay, so that's why we're getting by with this start at 0 and end at 1. Okay, so this understood right here, the left position is start, the right position is basically your monitor stop, right? So again, when you look at these are position based, and this is enable. So we would have to enable the second one to see that, right? So I just want to kind of briefly kind of give a good solid update, because again, it's been a while since I actually talked about this this instruction, the MAOC instruction. And I wanted to give an updated video because, again, this is on version 32, and the last one I did was on like version 20. Again, this is about the same logic that I showed you last time, but I want to give you more in-depth and understanding about how that works, because I can't stress that enough, that understanding the way your servo is set up with this instruction will help you with success throughout, again, controlling whatever. But again, also too, note that your output card that you're controlling needs to be set at that, right? So what I can do right here for my outputs, I can take this, I can come in here, take this if I want, and the way I even have it set up, right? So the way I have it set up right now is I can take this and come over here, add an instruction right here, and add this in the very bottom, and move what I'm doing here, paste that in there, and put that in my outputs, right? So if I wanted to, I can put this in my outputs, which I can just basically grab from right here and go right here to my data right here. So I'll copy that and then go right here and throw that right there, paste right here. So this will actually cut on those outputs now, and this is based upon the actual real world outputs cutting on my actual trainer, right? So this is, again, cutting on my actual trainer. So, but also too, what I want to actually address that we haven't actually talked about is the fact of when you're cutting off your MOC or MAOC instruction. Okay, so when you're cutting off, the bits are going to stay in the same state that they are. So it's very important that if you come in here, if your system is stopped and it's not active anymore, that you do a MDOC, which is basically a disable. So this is an arm, this is a disable, right? So this is a disarm. And then what you're doing is you're basically coming in and you're disarming all, and then you're coming in and moving a 0 into your output cam, and you're moving a 0 into your output cam up here. All right, so you're doing a 0 into, this would naturally be your again, your card, your output card. So you want to make sure you 0 out, you force a 0 into those specific indicators, right? So if you don't, then what's going to happen is the bits are going to stay high. The bits are going to stay on. So again, so however you want to, if you want, like say for instance right now, if I stop this, if I come in here and stop it, it's not going to shut off the bits. You see those bits are still, they're still on. Now, if I were to say that there's no motion, right? Let's just say for instance, I wanted to have, I was monitoring this jog. So if I wanted to know if it was actually running in the scenario that I currently have, what I can do is I can come in here and grab this jog right here, come over here, and actually say, oh, by the way, if the system is stopped, I want to actually come in here and turn this off. Now what I can do is I can say, well, I don't want to create a new one. I want to actually paste this in here. I want to paste that control in there, and I want to use the IP bit, right? So if the IP bit is not on, then I want to force a 0 in there. So what I'm saying here is, okay, so I want the actual system to be disarmed, right? So we can come over here and make sure it's disarmed. And what this is doing too is this actually, so I need to throw this IP up here as well, so that it doesn't try to rearm every single time I'm doing this, or they'll sit there and counteract each other. So I need to make sure that the jog is there. So here, let's do this. Let's come in, and you can see the live effect of all this stuff. So again, the disarm is here. We're enabled. We're done. But the purpose of what we're doing here is we're forcing a 0 into the actual output cam. are the outputs of that's going to be controlled through here, right? So we're forcing a 0 into here. So if we were looking at our profile, we would be 0 here. That's not because we're not running, right? So if we were to run, if we were to turn our servo, we could see that. Now, when we run, so if I were to come back here and start running again, it's going to pick right back up where it left off, right? So see, you start seeing the outputs come on. You start seeing the outputs start firing back again. And again, we're a lot slower now because we changed the speed. But again, I wanted to actually show that, right? And these are commanding at a different point, so that's where we're at. So hopefully that gave you a lot better understanding about this. So the key points I want to, and I know this video kind of ran long, but the key points I want you to understand about an MAOC instruction is that you understand the way your servo is set up. You understand too that when the MOC or MAOC is not actually active, or say it's active but the system's stopped, the system's not running anymore, then you want to shut it off. You want to shut off the actual outputs, right? Because generally speaking, it's going to be the output is going to be right here, right? So this would be your output card, right? In this case, what I've done is I haven't did my output card. I just mapped it over here in the simple illustration to show you how the outputs would cut on and cut off. But in the case of a normal atmosphere, you'd have your outputs right here instead of an alias or instead of just a raw tag like I have. But again, the thing I'm trying to highlight here is making sure you disarm it and making sure you force zeros into it. So if we stop the system or we cut it off, right? So if we stop it right now or we cut it off again, so see, this is the IP. This is not, the IP is not off. So we've actually disabled the whole thing, and we did the proper indication right there. That's exactly what should happen. So if we cut right back on, and the reason it didn't do it before is because I edited it, right? So now it's back on, it's back running, back controlling bits. Okay, so you see it's fully active, it's running through controlling bits like it should, right? All right, so just to verify that, if you wanted to see that again, pull up the cam right here. You see it? Okay, so now if I stop it, if I come up here to the stop, it's going to come in and it's going to disable the MAOC command, right? And it's doing that from here, right? So when I did this and this was enabled, it shut that off. It also forced zeros into here, so there's no actual bits live, right? There's no outputs live. Now the focus point here again is the benefit of actually cutting on outputs at a high speed rate for any given scenario you want. Like I told you, you can use it for air blast, you can use it for cutting, you can use it for different things. That depends on how you set up your actual cam, right? It depends on how you set up your cam. Now again, when it comes down to it, you need to know the way your servo is set up, you need to know the way your function is. So hopefully that adds some good clarity to the way that the MAOC instruction works and the way the disarm. So make sure you're aware though, once you use one of these MAOC, you should also have an MDOC, which again, one is an arm, one is a disarm, just like you would a regular arm event command or something like that for servos. This is a good solid way to control an output, like a standard output for your output cards through a controlled manner from your actual servo, whether it be position, whether it be whatever, however you want to do it from a servo based system, right? This is the most accurate and functional way to do so, right? So I want to make sure we stress that, and that's the reason why this command is so powerful, right? So it takes your servo position that you have programmed, and you are able to set a command position or even build a cam, right? Build a cam and load the cam differently every single time this thing fires, right? You're able to do that. And to do the cam editor, you just simply go in here and edit this however you want to. So hopefully that added some clarity and that helped you gain some knowledge on an MAOC and an MDOC instruction using this again is the Studio 5000 environment version 32, and hopefully that gave you some good solid information, and we'll see you guys on the next one.